Alright, starting to sign up for classes for next semester. What do we got so far? Still got a few to get. We got Introductory Computational Physics, Intro to Atomic Physics, Intro Quantum, and Public Speaking. One of these is not like the other. I'm about to go meet with one of my professors, Dr. Terzic, to just have a little talk. It's about 10 a.m. Okay, so when I met with one of my professors, I actually got offered an internship this summer at Jefferson Lab for kind of like theoretical physics with accelerated physics. And I told my mom about it, and I'm about to walk in the house, so I'm going to record her response. I hope it's like actually enthusiastic, or else this will be awkward.
Neil and Kathy, hey!
I was like, I'm gonna record my mom's response. I thought it was gonna be, but I guess you were upstairs, so it wasn't as loud. Today's actually gonna be a pretty cool day. So I'm about to go tutor some differential equations, and then I'll have thermodynamics. But alright, so the fun part, it starts when I have my SPS meeting. So we're doing that. We're voting on like who's gonna be the next president, who's gonna be VP, stuff like that for Society of Physics students. And then I have a meeting with one of my professors because your boy got an internship at Jefferson Lab in Newport News. So I'm going to talk to one of my professors who I'm working with about like what's expected of me, what the project entails, stuff like that. And yeah, so it should be a pretty fun day. So I'll go over more of that later though. So I'm the new president of SPS now. Your boy's the president now. I hope I don't get assassinated. This week has been so cool. Like, I got the internship at Jefferson Lab. I have to go there tomorrow to learn more about my project. I became the next president of the Society of Physics students. Things are looking up. It's awesome. Much needed. Alright guys, just got to Jefferson Lab. I'm meeting with the director of the accelerator division to kind of talk about what my project is. So, I don't know if you can see necessarily, but this whole building is, I think, called the CBAF building. I have no idea what it stands for. It stands probably for Center of Big Accelerator Physics, spelled with F, probably. But yeah, so it's kind of funny. I was in such a rush to get here today because when I looked at the GPS, I read 33 MI. I was like, oh, it's only 33 minutes away. But it ended up being miles, and it took me an hour to get here. So thankfully I wasn't late though, because I was too anxious, so I woke up at like 6 to get here. It's about like 8:30 right now, so I'm about to go in, meet the director of the accelerator division, and try not to pee my pants. Crap, too late. Oh, it's also my dad and my stepmom's anniversary, so if anyone's watching, if you could drop like a happy anniversary, Randy and Jillian, that would probably make them pretty happy. Okay. Enough of that. Alright. Hello.
Hey!
Hey, killer.
Gosh!
Happy Easter.
Happy Easter.
Happy Easter!
And happy anniversary.
What is that?
It's a video camera. This is your first anniversary as a married couple.
Yes, it is.
Do you guys have like a new anniversary resolution? Anything you want to do different this year?
We did a heck of a lot in 1 year.
Sure did.
We got a dog.
Hi.
What's really up there? Alright guys, it's Saturday and I have exactly 4 days until finals start. And I can't exactly study for them just yet because I have to do a bunch of lab reports before Monday because I procrastinated on finishing all my lab reports for experimental physics. So I'm going to be doing that all day today after I go to the gym. And then I have to do some partial differential equations homework, and then I have to do a take-home exam for thermodynamics or statistical mechanics. So it's gonna be a busy like next few days. I mean, I brought it on myself, so well. I also don't know if I mentioned this, but I have to learn 2 different programming languages by next semester because my professor for my senior thesis wants me to do it in Fortran, the programming language Fortran, and then my mentor for the internship wants me to do that in Python. Let's talk about what a senior thesis project is. And I can't speak for other universities, I can just speak for mine. So every senior has to essentially do a final project. And that project isn't like a summary or a book report of something that already exists. You're supposed to be helping a professor. They're typically gonna have like a bigger project that they're working on, and they're gonna need someone to do some of the grunt work. And for example, one of my professors is doing stuff with lasers a lot. I don't really know what it is. So one of my friends, David, his senior thesis project is making sure that the circuits that they use for all of those lasers and stuff is working well. Like that's his project. So, but mine, since I'm terrible with my hands and I can't build anything, I asked for a more theoretical senior thesis. So luckily my professor for electrodynamics is a theorist, and I was like, hey, y'all got any work that I could have? And he said that I could work with them on this project involving positron scattering. At low enough energies, the positron can come by regular matter and kind of dance around it. Like it doesn't have enough energy to quite leave the like the force that the other particle is exerting, like pulling on that. So it almost looks as if that antimatter and the regular matter are in orbit around each other. And when that happens, they call that like new atom positronium. So I think what my senior thesis project is going to be about is kind of describing the dynamics of these forms of antimatter, these positrons, and taking those kinds of interactions into account. I mean, I still have... The cool thing about a senior thesis project is you get a lot of time to solve it. In physics, so I don't know, like a homework assignment or something like that, like I don't think I've ever spent more than like 4 hours on one problem, 4 or 5 hours on one problem for physics. This problem, I'll have an entire year to solve it. This is a nice little dry run because, you know, when you're going to get your PhD, you're essentially given 4 or 5 years to solve one problem. So if you can't do 1 year to solve one problem, that's a good indicator that maybe a PhD isn't quite for you. Yeah, so I'll start that next semester, and my professor for that project actually already emailed me like a paper on positron scattering, and it was just riddled with quantum electrodynamics, relativistic, like ENL, like all this stuff, and I was like, oh my god, this is so cool. It's way over my head right now, but it's just cool knowing that, you know, 6 months from now, whatever, it won't be, and I'll know it, more or less. I regret procrastinating on these lab reports so much now. Oh my god. So I finished my lab report on the double slit experiment and on NMR spectroscopy, and now I have to do mine on rubidium saturation. I have to do one for the Frank Hertz experiment and for something else that I did. So I'm still working on my lab reports before I can get started on my thermal take-home exam. And for the upper level experimental physics classes, we don't really use Microsoft Word anymore. We use this kind of programming typeset called LaTeX. And though it kind of looks intimidating at first, it's actually really straightforward to use, and it makes your lab reports look beautiful. But it is a bit of a learning curve at first. So I've finished 3 of them, and I have 2 more to do, and then I can get started on my thermal take-home exam, and then I can do my partial differential equations homework, and then I can start studying for finals that start on Wednesday. Cool. So I'm just about done with my lab reports that are due tomorrow. I just have 1 more, but it's due by midnight, so I can do that. And I moved on to trying to finish my statistical mechanics take-home exam. And it's actually kind of interesting. It's fun to do. It's so different from what we were doing earlier in the semester, because earlier we were doing just thermodynamics, classical thermo, which frankly I find kind of boring. So now we're doing statistical mechanics, and it's got lots of hints of quantum mechanics in it, which is pretty cool. So we're doing a lot of problems involving degeneracy and probability that particles exist with certain energies and stuff like that. Look at a problem you could be asked in statistical mechanics. Consider an ensemble of N-hydrogen diatomic molecules in thermal equilibrium at a temperature 300 Kelvin. The hydrogen atoms are considered to be at their equilibrium separation of R equals that. In treating the rigid rotator, we use a parameter B to parameterize the energy as that. The quantity B equals h bar squared over 2 mu, blah blah blah. Show that the numerical value of the constant B is 1.2 zeptojoules. Calculate kT and show that's the numerical value. Then we got stuff with a partition function. So we've got the integral right here. This is just a constant, so don't worry about that. Of e to the minus a constant times v squared times v cubed with respect to v. So what I did that I thought was pretty clever was, so I let u equal minus v squared, du equaled minus 2v dv. So what I was able to do was I was able to call this v cubed minus 1/2 u du, because we got a v in the du and we got that there, so multiply it out to v cubed. But that was like the most tricky u substitution problem. And the funny thing is when you do the u substitution, you still have to integrate by parts. We're doing Fourier transforms and PDEs, and I just thought of a good movie idea. We're gonna have a movie, and it's gonna be called Fast and Furious. Because like Fourier is is what we're learning. We're Fourier transform.